Well, thank you very much, and hi everyone online. I'll just share screen and get the presentation going, and hopefully everyone's got visibility there. I'll look at certainly great to be able to speak with you about the Adelaide Oval Hotel redevelopment, and particularly the influence that CLT had on both the design, construction, and in fact completion process. I'm going to sort of speak for a number of slides in terms of giving an introduction, I guess more of an architectural perspective on the design components, and Nick's going to provide obviously some engineering and a little bit more technical information. This slide is just look a bit of background here. The hotel effectively represented stage 3 of the major redevelopment of the Adelaide Oval, and for those that know the ground and the space, it's an incredibly unique and beautiful part of Adelaide. The western stand on the far side of this image was completed in 2008. The main redevelopment of the rest of the Oval was completed in 2014. And then, and very interestingly, the Stadium Management Authority came to us with a unique idea to effectively build a hotel on the outside of the eastern stand. It was something that had never been done before in Australia. In fact, we'd never sort of seen it in any of our stadium projects locally, but it had been done overseas. And so we did begin to look at some of those examples from overseas in the States and in Europe, where hotels had been integrated into stadium developments. Interestingly, the majority, or in fact all of them, really overlook the ground. And so our proposal for the Oval Hotel was quite different in that it would wrap outside the ground and be as much of a parklands experience as it would be about the sport itself. In terms of the context, just looking at a three-dimensional view of the ground, the idea was to delicately wrap or effectively laminate a hotel on the outside of the eastern stand. Nick will talk to you about some of the structural challenges that came with that. But interestingly, spatially, because of the way that the stand was originally designed, this was very possible. And in fact, once we recognised this challenge, it gave us a really great design opportunity. The hotel's composed of 3 key components: a main entry reception pod, and then 2 hotel wings that separate and work either side of that central entry. A few quick facts and figures. It's a 138 room hotel, so very much boutique in size, over 4 stories. There's only just over 6,500 square metres of GFA, which is quite small for a hotel of this type. That's because if you look at the last bullet point, and we would often say 50% of this hotel already existed. So the restaurants, the bars, the amenities, the security, a lot of the logistics, a lot of the back house spaces already existed at the Oval. In fact, all we were really doing was building the rooms, building the reception pod and lounge, and then tapping into all the functionality of the existing eastern stand. It was finished in 2020 and was completed in a very quick 12-month construction program. This was only really possible, and if we look at all the project team members, at about 60% through to the design, at an early tender, Built Environs won that tender, and with XLAM actually brought this idea of bringing a CLT structure into the project. So this was actually an innovation that was bought from a constructability perspective. There was advantages on program, there were some advantages around structure, acoustics, various other benefits, and there was a lot to like about this proposal. And when we started working with Built Environments and their team at the 60% stage, we really integrated and brought that into our thinking through the design. A couple of quick slides just to explain the project. So you can see in plan form, so the central reception pod and lounge, which actually floats above the eastern entry gate, and then both wings of rooms, both to the south and to the north, are single loaded. So every room faces out, has a view. Standard rooms, premium rooms, and different room types are distributed over the various levels, and they were all sort of delicately and snugly and discreetly positioned within the building. So the existing stair core and lift shaft and the stair cores, interestingly, there's actually quite a large recess in the stand. A number of people have asked us, did we plan for this hotel all along? I wish I could say yes, and that we'd been that inventive, but no, there was just the spatial provision there. for us to insert those rooms and provide those different experiences for the guests when they eventually arrive. In terms of the scale and I guess the language of the building, it was always intended that it would sit delicately within the context of the existing stand and the existing roof forms. And I guess a lot of the sort of iconic structures of the Oval would not be affected and would feel like it was always intended and meant to be. So a couple of photos here of the completed hotel before we get into some of the CLT inner workings of the design thinking and philosophy. So you can see the central pod under the floating on top of the existing entry gate. You can see the wings stretching on the south and north, some premium rooms, other standard rooms, and so forth that are distributed either side. What a lot of people wouldn't realise when they go to the hotel today is that actually the great secret about the construction of the hotel, about all of the floor slabs, all of the structural walls, in fact, all of the structural frame and roof planes that Nick will show you in the engineering phase that's coming up, was actually delivered in CLT. And for this sort of application, particularly a hotel in a situation we had to touch the structure very lightly, it really was an ideal solution. And all the framing for all the rooms of all the levels, once we got above a steel structural deck, were provided in that CLT material. Some before and after shots. So again, you can see all the CLT wall and floor panels stretching up to the roof form. Some of the most premium rooms in the hotel. There are two major suites, which are 56 square metre, very much rockstar hotel rooms in the top corners were a combination of CLT with some steelwork on the facade line. Some of the wings of the hotel, the CLT, which is then clad in obviously some waterproof barriers, and the final cladding, which was a combination of bronze and some stainless steel fins and also some aluminium cladding, and then the completed hotel. So it's a little bit unique in that a lot of these projects you might see CLT having expression externally or internally. It was really the structural frame and the incredible sort of acoustic and other beneficial properties that material brought to the project. And this is a shot just looking down the concourse of the completed work. It's of course being done in a very historic and important setting, and everything we did as part of this stage 3 proposal was to be benchmarked against our work on the previous 2 stages from a level of quality and finish. This is a construction shot of the main reception pod. It's a very long linear space. It has quite remarkable views back out to the cathedral that you could see through there, but also the incredible parklands views that are so unique to Adelaide. So forming all the floor slabs in this occasion, and then the completed reception pod, following all the interior refurbishment work or interior work. We did the interior design with Car Design as well out of Melbourne, and a lot of thanks to their team for the incredible collaboration work with them as well. What's really interesting with this space is that everyone who went through the East Gate actually looks up and sees the hotel lobby reception above them as one of the key entry sort of gateway pieces through into the Oval. And just a shot from the outside with that artwork. We sometimes think it's a bit of a shame we couldn't expose a little bit more of the timber, in particular this shot, which is one of my really most favourite shots of one of the hotel rooms during construction, almost completed in structural form. And you can see obviously all the wall panels, all the floor slabs, all the roof slabs, all the structural work around this room, complete CLT. This is actually a fairly appealing aesthetic from a completion perspective. However, it was of course clad out to provide the final room finish that you can see in this photo as well. A lot of people who stay at the hotel remark on the acoustic properties and the separation that's achieved in between rooms and to the corridors, and also through the double glazed systems out to the street. And I know that CLT has had a big impact on that performance as well. One of the premium rooms. Of course, in hotels, a lot of corridors have surfaces reticulation. A lot of services work was undertaken to coordinate with the CLT structures during the design phase from 60 to 100%, and allow for the incredibly complex servicing of all the room requirements, all weaving beautifully through the CLT structure and providing the final completed works, in this case, the corridor and approach through to the reception area as well. Okay, I think I might hand over to my colleague at this point. Nick, if you're on the line, I'll happily continue to share screen. Just let me know when you want to work through the slides. Thank you, Nick.
Yeah, thanks, Adam. And thanks, Wendy, as well, and Wood Solutions for the opportunity to present. So just to provide a bit of context, I'll talk a bit about the structural design of the hotel. And as base build design engineer, Mott MacDonald are responsible for the primary structure. And then we coordinated with XLAM and their design engineers, Vistec, to coordinate and design for the CLT to be installed later. So I'll get into a bit more detail about that later. So what I'll start talking through is how the structural design evolved initially. So as you can see, and Adam's talked about, quite a limited site around the stadium. So we had a relatively shallow structural depth to be able to achieve in the weak axis of the building, which was something we looked at from the beginning, and also we needed to allow a certain amount of space on the exterior of the building for emergency vehicle access as well. Go to the next slide, please, Adam. Just a few additional sort of constraints, you could say, in terms of access. You can see sort of this is the stadium before the hotel was in place, where the egress stairs are, where the gates are, and where the access around the stadium and into the stadium is. So obviously, the stadium being active throughout the construction program, we had to make sure that the design of the hotel, allowed for that access to continue through construction and then post construction as well. Next slide, please. Maybe not constraints is the best word to use here, but challenges with the design of the stadium. And I don't know if Adam, if you want to talk to this a little bit more as well, but the form of the hotel, does replicate some of the existing forms and structural forms within the stadium. As you can see, the V-shaped columns was something that was replicated on the hotel, and actually something that was used to structural advantage, which I'll get into later. But also the permeability through the east facade and that floating reception pod, as well as some of the materiality and finishes that we use on the hotel as well.
I will just add a quick comment, Nick. I mean, you've hit on a really good point here. Our brief from the client was to, yes, do something that was consistent with the original design redevelopment from 2014. You can see the images of the south stand and some of the east stand, but they did actually want to take it to the next level as well. So it was almost about, not only being at the same level, but enhancing and really providing a much greater level of experience for those coming from a hotel, because a lot of people aren't coming just for sporting events. They're coming to stay in the hotel as a destination in its own right. So where we started with the existing structure, we looked at exactly the overlay of the hotel, as you can see here on the existing structure. So to the south, just to the left of screen, there's an existing sort of post-tension band beam slab, which spans onto columns and onto a retaining wall to the edge. And then to the northern wing, we've got a bit of a shorter retaining wall and some band beams as well. So we're relatively limited, I guess, in where we could land the vertical structure from the hotel. And then similarly for the reception pod as well, it's sitting above some existing band beams as well. Next slide, please, Anne. So the plaza slab, which sits above 2 stories of car park below, plaza slab had a pretty heavy load allowance. Initially, it was designed for 10 kPa live load, which allows for essentially emergency vehicle access, and also a heavy imposed dead load to allow for a high level of screed and architectural topping above the base structure. So we utilize that high load allowance to actually re-rate the plaza slab in terms of what load it would take within the footprint of the hotel, and use that to provide additional capacity in lieu of foundations for the hotel, which I'll touch on later. Next slide, please. So this figure here it sort of shows in cross section how the hotel sits adjacent to the stadium structure. So one thing to note is the structural systems are
somewhat independent, but the hotel structure relies a lot on the stadium structure as a lean-to, as you probably see here. So the stadium structure works with post-tension slabs and a concrete shear wall core shown there. So that's the system that we had to work with, and I'll show you how that integrates in the next slide. In terms of pile foundations, we essentially have the ability to install new foundations just due to an access and operational requirements of the stadium. So we really had to push the existing foundation design, got a lot of the pile testing data and see, sort of reviewed how that additional load from the hotel would affect that performance. Able to use that to provide an upper bound on what load the foundations could take, and then we had to design the hotel to that load, which was challenging and as I get to later, it was a challenge before we got into the CLT supply, which made all of our lives a lot easier in terms of load. Next slide, please. So with these V columns that I was talking about previously, they were advantageous from a structural point of view because we could focus the vertical load and weight of the structure where we wanted it onto the existing structure below. And through concept, we looked at a few different ways to do that, as you can see, and each option had different implications in terms of structural strengthening to the existing structure below. This involved strengthening of columns, piles, band beams, a whole range of things. And we sort of got to the point where it was becoming quite challenging to achieve without strengthening works. So at the point of design here, we assumed that we were going to need to do some strengthening, and it was just a case of trying to minimize that as much as possible. Next slide, please. This is just a bit more detail around the column strengthening, some of the details we used. You probably skip this one, Adam. Thank you. And we were potentially looking at introducing some additional beams within the podium structure. As you can see in that image on the right, all of that basement area below the premium pods is all used for plant for the hotel, for the stadium, sorry. So any sort of construction within that area would have meant the plant would need to be closed down temporarily, which would have prevented use of the oval for events, which is obviously a big thing for the Stadium Management Authority. So we had to look at ways to avoid doing that. Next slide, please. So essentially, what we dealt with at this point was a roadmap to bring the project back on a budget and to get it to work from a strengthening point of view. So one thing we looked at primarily was a lightweight structure. So that essentially ruled out any form of concrete design from day one, and also looking to maximise prefabrication to minimise the amount of site works and trades that would be needed. Next slide, please. So we looked at a bit of back and forward with Adam and his team to realign some of the columns and how that affected the building envelope, in particular for the premium pod modules. What we ended up with was some complex steelwork, as you can see on the left, with some two-way Virendal trusses to provide that two-way cantilever, which was quite complex coordination exercise, but it was what was required to be able to avoid strengthening to the structure below. Next slide, please. We also looked to hang part of the hotel structure off the existing stadium structure, which we worked through. There were some modifications to the existing stadium structure to allow the hotel to sit against it, and that brought us some additional capacity within that structure. So we looked at sharing some of the load between the hotel structure and the stadium structure as well. Next slide, please. Thank you. And this is a little bit more detail about how that worked, how we tied it in with some circular tube struts back to the stadium structure. So we had some key points, some key diaphragms within the stadium structure that we tied into. Next slide, please. So at this point, we were talking about a lightweight structure. Obviously, the majority of the structural weight is in the floor system. So we looked at a few different systems, as you can see here. One of them being lightweight steel floor joists on a structural steel frame. We looked at composite metal decking, but it didn't really meet our load requirements. It was too heavy. CLT, of course, and then also some other proprietary aerated concrete solutions. So all of them had their advantages. And at this point in time, we were struggling with the weight consideration. So we progressed with the lightweight steel floor joist system, which I'll get into a bit more detail after. Next slide, please, Anne. So essentially what we had is we've got vertical supports back to the existing structure at about 11-metre spacings. And our structure in between didn't span that far at every level. So what we've got is a large transfer, I guess, grillage structure, you could call it, at level 2, which you can see is on the image on the right. And then the individual bays in between is essentially the room layouts above. So we could frame up internally between those in each internal room wall with steel framing and steel floor joists between. Next slide, please. These are some sort of concepts on what the level 2 structure looked like. We had some key clearance requirements below. I don't know if Adam, if you want to talk about that, but early days we were really pushing the structure design to achieve those clearances below, and that was a back and forward between the weight of the structure above, you know, how far we had to cantilever the level 2 structure, and where we could get support in the existing structure below. We ended up with a solution that was relatively shallow, but still it was pushing the clearance requirements below.
Yeah, I guess just to add a comment, Nick, we couldn't make the hotel any taller because it wasn't allowed to get above that datum and affect the roof line. We also have an active public concourse, so we were being sort of pushed in both directions to get the hotel as slender as possible from a structural depth perspective, but still get 138 rooms across the 5 levels. So the clearance to the underside was pretty critical as a public concourse that is so heavily used for you know, obviously football, cricket and other events.
So this is just showing an isometric of the structure we developed prior to going to tender, and it was a steel column solution, which is obviously similar to what's within the existing stadium, and we've got some complex Virindle trusses. So the reason we had to keep them open was to allow passage through the corridor as well, and also any bracing in between was going to play some havoc with some of the internal linings. So that was the solution we ended up with, and it was pretty heavy as it was, and it was a solution that we had to live with at the time, but we were able to rationalise it a bit further later on. Next slide, please. Yeah, just another similar detail to show what the steel solution was. Next slide, Adam. So just to give you an overview of the final tendered solution that went to market. You can see the steel framing working, the trusses, the steel V columns, and the bracing as well. So a lot of steel in there, as you can see, and that had some complexities in terms of fabrication and erection. We, as you can see with the radial grid that the hotel followed, it meant that every structural member that ran perpendicular to the grid had a different length. So as you can imagine, that was a nightmare for any sort of fabricator, as well as the time required to erect all of the steelwork was considerable. So that was where it was. Next slide, please, Adam. And at this point, Built Environments awarded the head contract, and they brought forward this solution with XLAM and Vistec to use CLT to replace the majority of the steel structure above. You know, in terms of just a high-level comment, for, you know, at this point of time, it's a considerable design change, but our team at Mott MacDonald were kind of blown away at the ease of switching structural systems at this point of time. The CLT is really flexible in how it works and fits in around the other structural systems. So you'll see more of that in the slides to come. Yeah, next slide, please, Adam. Just to give a bit of an overview, you can see this is the final solution as it was built. We've got CLT floor, wall and roof panels, and they're sitting above that level 2 steel transfer structure that was similar to what you saw previously. In terms of lateral stability, we're getting lateral stability from the CLT shear walls. So the ones that you can see align with the V columns below, they're designed to be slightly stronger and stiffer and provide a large sort of shear wall response. And the CLT floors between those shear walls provide the diaphragm action. We still had to keep a bit of steel in the premium pod areas where we've got where we had to retain those cantilevered zones. We just couldn't get the stiffness without the steel, but the advantage of the CLT is they were able to, CNC it and fabricate it to a high level of tolerance that enabled us to place those panels in and around that steelwork with relative ease. As you can see, also the foundations as well. They were the only 2 piles that were installed for the whole building, and they were out in ground. They weren't in existing structures, so that was relatively straightforward. But we were able to use the rest of the existing structure, which I think was a pretty good achievement by the project team. Next slide, please. Yeah, as I was saying, just the only 2 piles, and then elsewhere we were supporting the structure off the existing retaining walls or columns down to the existing foundations. Next slide, please. So the level two structural transfer structure, you can see we initially designed it just to support the dead load of the CLT panel above. But what we found is once we started coordinating with XLAM and their engineers, Vistec, was that the CLT wall was actually acted as quite a stiff, deep beam, and it could help assist control a lot of the deflections that we're having on the facade line. It increased the amount of fixings that we needed between the CLT and the steel, but it provided a lot of additional stiffness to the system that we didn't originally account for, which was a really good outcome for the project. Next slide, thanks. Just a few images here showing the sort of size of the steelwork that we dealt with at level 2 in the CLT and how it framed in around it. We had some difficulties in terms of some challenges in terms of getting the steelwork to sit, I guess, with the CLT, and we had to make sure that the fixings were designed for the correct restraint loads and allowed for the differential shrinkage requirements between the materials. We got there in the end, and it was a relatively straightforward erection procedure on site. Next slide, please. These are the V columns, which ended up being in precast, and it's probably a good comment to make, as we used pretty much every material on this site you could think of. We had precast concrete, structural steel, CLT. I'm sure there was something else I'm forgetting, but we had to deal with a lot of different systems, and the way those systems interact and behave differently sort of necessitated a pretty bespoke structural design. Yeah, next slide, please. It's just showing a few images of the precast columns in fabrication and during erection as well. As you can see, some of the V columns, the typical V columns with the, I guess, the double leg provide a relatively stable structure, but we've got a few V columns where it's not really a V, it's just a L, and that provided a large tension force back into the existing structure, which we had to design for as well. Next slide, please. These are the premium pods, which we talked about previously, and the steelwork that were relatively unchanged between the solutions. But as you can see, it's quite heavy, and there was a lot of steelwork that went up to support the premium pods above. Next slide, thanks. Just also showing a little bit more about how they were working and the size of the members as they were installed on site. Next slide, thanks. So with regards to the CLT wall and floor panels, so you can see that they're used to frame up the primary sort of structural walls that are aligned with the V columns. They're not also the internal walls between rooms, which we also use structurally, vertical load-bearing system. The CLT panels would span across the walls, so there was some continuity there as well. But we obviously worked with XLAM and their design engineers, Vistec, to make sure that the structural system was transferring load onto the primary steel level 2 structure, sort of as we designed it for. Next slide, thanks. Then just a few images of the CLT panels going into place. There's just a direct screw fix into the steel below for level 2, and then just little screw fix in between panels, as you can see. Next slide, please, Hannon. So as I touched on before, the lateral stability of the system. So we utilized the CLT walls that were on the primary grids as shear walls, and then those shear walls themselves were supported by the V columns down at Plaza, and then also with some struts back to the existing structure at discrete points. And I guess the tricky part, if you want to go to the next slide, Adam, with that is that you've got steel, which is a very high strength material over a small mass, whereas CLT is it obviously is highly stiff, but it requires slightly more material to be able to resist the same load. So we had to transfer a lot of load through the CLT, which required a lot of fixings, which was an interesting design challenge that we had with XLAM and Vistec, but we were able to achieve it in the end, which was great for the project. Next slide. So with the reception pod, as you can see from Adam's images previously, there's a steel roof structure sitting above CLT flooring, and then that CLT flooring itself sits on a steel frame below. If you go to the next image, please, Adam, you can see that this structure very, very flexible in the sort of top to bottom direction, as you can see in that bottom image. So we had to utilize the CLT as a really quite a stiff diaphragm to be able to transfer the lateral wind load and seismic load back into the existing cores, which you can see at either side. It was a relatively flexible structure that we had to work through and refine considerably to get it to work. Next slide, please. One of the other good outcomes for the CLT, which was really, I think it was a great result for the project, was the fact that we were able to replace a lot of the structural steel with CLT and sustainability outcomes that has. It's sort of I think a landmark project for Adelaide in this space, and where obviously as an industry need to be doing more of this. So it's good to see the impacts that a project like this has. And you can see just on the top right there, the amount of carbon that's sequestered by using the timber is considerable. And as I like to approximate, it's equivalent to planting, 1.7 Adelaide Ovals full of native timber forest. Next slide, please. So some of the key challenges we talked about previously a little bit was the coordination between ourselves as a base build structure designer and XLAM and Vistec designing the CLT. Nowadays, obviously, we like to use our analysis models a lot to do our design, and we were able to sort of use similar software and transfer between each other's models relatively easily to make sure that each structural system was working as they needed to in response to one another. Next slide, please. The connection design itself. So I guess obviously with connection design for steel and timber, it depends a lot on the material strength as well as the actual fixings themselves. So there was a lot of back and forward between us. We need to go in and install an additional beam to support a panel. It wasn't a necessarily straightforward coordination process. So we were able to work well with XLAM to make sure that happened efficiently. And as you can see, there was some additional sort of requirements back and forward for the CLT, for the steel to be able to support the CLT with additional stiffening plates and the like, things like that. Next slide, please. Then we looked at obviously the original roadmap was talking about maximising prefabrication, and that's one of the key advantages that CLT brings. Is it's designed to a high tolerance and high finish. You can achieve your complex shapes that the project demanded. And then also, it's quick to assemble on site, less parts, and able to achieve that really, really short 12-month construction program, which would have been difficult otherwise. Next slide, please, Adam. I think that might be it, actually. It is. You got anything else to add, Adam? Otherwise, we might be on to questions, I reckon.
Oh, look, I think it's a really great summary of the engineering process, and I'm sure everyone would appreciate online the value that the CLT added, and it obviously made what was a very, very challenging structural task a little bit easier. In fact, probably the benefits in terms of that lightness of structure and savings in program, may have made the difference in terms of the viability of achieving in the, obviously to budget at a time. I mean, that can't be understated. I'm not sure everyone that visits the hotel and would see this image would appreciate the amount of CLT content through the frame. So I think it's a really good achievement, and I think a lot of credit to yourself, Nick, and to Mott's, and also to Build Environs and XLAM and their engineers as well for bringing that thinking to the table at the 60% stage. It was certainly a big win for the project.
Yeah, definitely. Thank you very much, guys. Adam and Nick, that was definitely a beautiful building. I must admit, I haven't had the opportunity to visit it just yet, but I have seen a great deal of the photos. And I agree, Adam, that it would have been lovely to expose a little bit more of the CLT in the hotel rooms, just to get a little bit more exposure, make sure people realise what's actually involved in such a beautiful structure. Now, guys, if you don't mind, I might reach out to some of the questions that we've got for today. The first question that was raised was, what is the design life of the hotel? Adam, would you like to address that one?
Sure. Look, I think, technically the minimum building life for this sort of project would be 50 years, but that's really a minimum. And all of the stages in this would be envisioned to be a lot longer lasting in that regard. So, I mean, hotels do from time to time do interior refurbishments, and we can imagine that one day they may wish to do a new concept for the lobby. They may wish to do another restaurant concept internally within the hotel itself, but the structure and the facade should be, anywhere between 50 up to 100-year lifespan.
That sounds fantastic. All right, just moving on to the next question. Can you speak about the combustible materials and how that was managed?
Yeah, I'm happy to start with that. Look, it's a really interesting discussion, because CLT actually does technically meet a lot of the fire and smoke indices requirements from a material properties perspective, and that's why CLT is so commonly used on projects and exposed and public projects. Not so much, certainly in South Australia, but in other parts of the world, it is used frequently. As during this project, and as I think it still currently is today, fire regulations did require us to put an additional fire check lining around some of the CLT in sort of firewall conditions, even though technically the material complies with the those properties themselves. So it's probably a case of some of the regulations, certainly in South Australia, need to catch up with what the actual material properties can deliver from a CLT perspective.
Sure. And I guess a basic question, would this project encourage you guys to use timber into the next design process or the next design structure building? Did you enjoy the CLT?
Oh, look, I think from our perspective, I'll answer first, Nick, maybe, but I think we definitely would. The only difference would be is we'd probably start with it from day zero as opposed to 60% through. I mean, a couple of things to mention: the way that we do, design three-dimensionally, and with, our BIM process, the ability to have a material that's really can be worked to from an exact perspective structurally, but also with services coordination is a real advantage. And we really can see a lot of advantages from a CLT perspective in our BIM model development. Yeah, I think if we'd started earlier on, it would give us the chance to go on the journey with the client and maybe expose a little bit of the material and get some of that, beautiful warmth into some of the interior finishes. I think this is only the second CLT or major CLT project that's happened in Adelaide. There's a student accommodation building in the west of the city. So hopefully this will be the spark to see a bit more happening in Adelaide, but I'd be very happy to use it again. And I think we may have a couple of projects in the wings, so we'll wait and see.
Yeah, that's good to hear. Now, Nick, you may have mentioned this, I'm sorry. Now, you talked about the change in the design stream, probably about halfway through the process. Can you just touch base on that again and say what was the reason for the change?
So I guess the reason for the change to the CLT was the tendered solution by the builder. And I guess previously, probably CLT not being a predominant material in the Adelaide market, a lot of the tenderers, were hesitant to consider it. So we were sort of working towards more of a business as usual approach at the start of the job from a structural design point of view. And then I guess the key changes and advantages that CLT brought was the lightweight structure. And Adam touched on the acoustics as well, but also there's some vibration issues with using lightweight steel structure. So a lot of them were key sort of design outcomes, but then also constructability and timing and things like that. It was always going to be a tight program, but the CLT definitely helped achieve that program in the end.
That's great. Now there is another question from Daniel. How do you resolve the acoustic issues between CLT and the steel structure, in particularly the flanking issues? If that makes sense, maybe Nick, I'll throw that one to you.
Sure. Look, it's definitely not my area of expertise. We had some pretty detailed acoustic engineering input into this job, and a lot of high level testing was done and whatnot. I guess in terms of our input to structural sort of effects on the structural design, there wasn't really much. I don't know if Adam, there was probably got a bit more to add potentially with wall linings and things like that, but.
Yeah, I think certainly the additional wall linings and insulation that was already envisioned and was part of the original wall build-up was utilised in addition to the CLT. Like you, Nick, I defer to the experts sometimes with these things in the acoustic engineering process that took place. What I can say though is that from having stayed there, myself and a lot of stories from people who stay there, the acoustic performance of the rooms in particular is really good. The separation between rooms and corridors is exceptional, and there's a lot of hotels where you don't get that outcome. So yeah, whatever the technical work that happened, it's been very successful.
Fantastic. Now there was a question. Please expand on what you were referring to as native timber.
Native timber. Was that? And that might have been a question to me. That might have been a question in terms of offsetting of carbon. So. More relating to if you were to plant, a native timber forest, it's a very ballpark figure. It's just to provide some tangible, numbers to the amount of carbon that is, sequestered within the timber structure. So, I'm not exactly sure what sort of tree that would be, what species, but I assume it's a native timber forest.
Thank you, Nick. Sorry, some of these questions are a little bit hard to answer when they're not directly to your slides being up on the screen. Another question from John. The fire requirements are determined by the National Construction Code, not South Australia regulations. Please comment on this.
Sure. That is a correct statement. There is a national code that we all need to adhere to, but the local factor is that the South Australian Fire Service is ultimately the ones who approve fire systems for the building. So despite the fact that you need to work to a national code, it's the local fireys who will ultimately sign off on any fire engineering or any fire applied solutions from an engineering perspective. And that does vary state to state. And I can tell you from having worked in Melbourne for a decade and other places that it certainly is different, and it is slightly local to Adelaide, because they have certain practices on how they want to deal with fire protection to public buildings. Nick did mention at the start, is a big part of this was maintaining access around the hotel. So I think it was the 6 metre clear zone is one important thing, and maintaining existing stadium access, but the material build-up and material properties was also something that they commented on and had to formally approve.
Great, thank you, Adam. Now there is a question from James. You've got some lovely exposed timber on the front of the building. How do you protect that exposed timber from UV weathering, especially if you've got a 50-year lifespan? What sort of maintenance is required on the external facade? I
think James might be referring to the blades and the screens that we can see on the outside. I think that might be the reference. That isn't actually timber. It's a Rimex stainless steel. So there's polished and mirror and matte Rimex fins. There's bronze cladding, and there is some aluminium cladding as well. So no, the facade systems that are exposed externally are all metal systems, and real metal systems. So real aluminium sheet, obviously bronze, and the Rimex stainless steel. So no, unfortunately, we weren't able to bring any timber linings. For example, the threshold around The portal of the reception pod would be fantastic in timber, but it is actually a Rhymex stainless steel. It still does give that beautiful glow and that beautiful warmth. In fact, you can sort of see a little bit of the way that the sunlight is kind of hitting the hotel, and it's one of the highlights early morning as the sun rises up. You get that beautiful, nice reflection. But no, unfortunately, not timber on this occasion. Maybe next time.
Yeah, well, definitely, it gives that look on the outside. It's definitely a beautiful building, and it makes you believe that it's a warm timber structure from the outside, even though it's not covered. Now, guys, it looks like we are running out of time. If there's any last-minute questions, I would like to address them. Otherwise, Nick or Adam, would you like to add anything before we finish the presentation today?
I'll look, just a quick one. I mean, we mentioned all the project partners on the screen. It was a really big team effort, and apart from, you know, myself at Cox and obviously Nick and the Mott's team, we've mentioned the builders and XLAM, but the client was a big part of this, and the Stadium Management Authority did come up with this original idea and challenge for us to laminate a hotel on the outside of their stadium. Government, departments that work through planning phases. There's a huge list of people that were responsible, and without all their contributions, it wouldn't have been possible. And of course, probably without the CLT game changers through the project was also been a big difference. So just the opportunity to thank everyone else involved in the project.
Yeah, I'll just add to what Adam said. Yeah, it's a project that, you know, our team, and I know Adam and his team would be very proud of every time we drive past it and go to the Oval to watch the footy or the cricket. So I think it's a great outcome, and it's definitely something that's inspired myself and our team to pursue timber construction solutions going forward. Yeah,
fantastic. Well, Adam and Nick, thank you so much for sharing your experience and your wealth of knowledge through the construction process. Definitely very challenging. You've obviously had to work in and around an operating supporting facility, as well as incorporating the hotel into the existing structure with CLT. A job well done. And obviously there is a big team behind you. Like you said, we need to congratulate all of the team that's been involved. Thank you once again for sharing your wealth of knowledge. And thanks again for also answering all the questions today. Thanks everybody for joining us today. And we would like to mention that there will the CPG questions, if you didn't hear them earlier, were: name 3 design advantages of using mass timber construction. Can mass timber elements be used to provide lateral stability to building? What is the predominant type of lumber used in the construction of cross-laminated timber panels in Australia? I hope you all enjoyed the presentation today. Once again, thank you for joining us. The next presentation will be on Tuesday, the 1st of March at 11 a.m. The topic will be performance and finishing and maintenance of natural timber structures. And the presenter will be Gareth Connell. Now, please, guys, if you do have a little bit of extra time, please make sure that you do check out the YouTube channel. The YouTube channel for Wood Solutions has a lot of different clips and behind the scene production. So you can also go in and just see how, how everything works in the background. Once again, thanks very much for joining us today, both Nick and Adam. Thanks again, and we look forward to seeing you all next Wood Solutions webinar.